Algebra 2, Common Core, the equation of a parabola. What we're going to see in this video is that if we have a little bit of information, we could get the equation of a parabola from this formula here. And this is one of the few formulas you're going to have to memorize in this course. You will have a reference sheet on your Regents exam like you've had in past exams, but this formula is not on it. So you do need to memorize this. I recommend you write it on your reference sheet when you sit down for your exam for the Regents, but will not be provided to you. It's probably the most complicated formula we have in the course that you're expected to memorize. But it's worth it because there is another way to do these questions, but it's a lot harder without this formula. So you really do need to know this. So what do we need for this formula to work? You only need two things. You need the coordinate of the vertex. We call that hk. I know h is the x value of the vertex, k is the y value of the vertex. Now we also need p, which is the distance between the vertex and the focus, which is also the same distance between the vertex and the directrix. If you remember from our last video, the vertex is right in the middle of the focus and the directrix. So the distance from that vertex to focus is the same as the distance from the vertex to the directrix. So you could get this distance in one of two ways. You could think of it as the distance between vertex to focus or the distance between vertex to directrix. It's the same thing. But we need that distance and the vertex coordinate. Plug all that into this equation and we could get the equation of a parabola. So let's take a look. So first question, derive the analytic equation of a parabola giving the vertex, that's one of the two things we needed, and a directrix. So we have the vertex, that's one of our two things. So all we need left in this problem is we need that p-value. We need to know the distance between the vertex and the directrix, or the vertex and the focus, it doesn't matter. I think it's helpful to draw a little sketch for these problems. You know my art skills are pretty bad with this tablet, but I'll attempt it. So the vertex is 2, 2. We know that's, in the first quadrant over here, 2, 2. And that's the vertex of the parabola. Now, I don't know if this is a smiley face parabola or a frowny face parabola, but then they tell me the directrix is y equals negative 15. So that's all the way down here. Y equals negative 15. And so if that's where the directrix is, that means the focus must be somewhere up here. And I don't know that coordinate, and I don't really need to know it. But knowing that the focus is above the directrix means that this is definitely a smiley face parabola. So it's going to look something like this. All right, but the p-value is the distance between the vertex and the focus, which would be tough since I don't know the focus, but it's okay because it's also the distance between the vertex and the directrix, which I do know. And the axis of symmetry has all this stuff in common, so what we're really looking at is the difference in the y values. The y value here is 2, and the y value here is all we have, negative 15. How far apart are 2 and negative 15? The answer is 17. Negative 15 is a distance of 15 to 0, and then we're 2 above that. So it's 15 below the y-axis, 2 above, a total of 17 apart. And if you subtract them, 2 minus negative 15, you get that also. But our p-value is 17. That could actually be used to find the focus. We don't need that here, but I know the focus is going to have the same x value as the vertex because it's on the same axis of symmetry. The axis of symmetry here would be x equals 2. It's the x value of the vertex. The y value, I just know that it's going to be another 7. If this is a distance of 17, this is a distance of 17. So it's 17 above this, and 17 above 2 is 19. So the focus here would be the point 2, 19. But I don't really need that. Again, what I need is the vertex, got it, and I need that distance 17, got it. So let's plug that into our formula. Now you have three things that get substituted here. P gets substituted for the distance. That's going to be 17. Y stays Y. Y stays Y, X stays X. Because the equation of a parabola has a Y and X. So don't replace those with anything. You replace the P with your distance value you get, and you replace H and K with your vertex coordinates. But the X is H, the Y is K. So remember, the Y's are on the left here, the X's are on the right here. But this whole thing could be flip-flopped if we wanted to. We know the left equals the right, but this is just how it is presented to us. So it's 4 times p-value, 4 times the distance value, times y minus the vertex y value equals x minus the vertex x value squared. So it's a weird formula at first, but you just have to memorize it and get used to it. And that's not too bad. So 4p would be 4 times 17 times y minus k. K is the y value of the vertex. Now here x and y are the same thing, but it's the y value, so minus 2, equals x minus the x value of the vertex squared. Let's see, 4 times 17 is 68 times y minus 2 equals x minus 2 squared. We could distribute over here to get 68y minus, I think that's 136, equals x squared minus 4x plus 4. That's your binomial squared. You could think of it as x minus 2 times x minus 2, do FOIL, or you could do the mental shortcut of square the front times each other double, square the back. But we want this to get down to the standard form of a parabola, which is y equals ax squared plus bx plus c. So we want just y equals. So the first thing I'll do is I'll add the 136 and add it to the constant over here. So we'll get 68y equals x squared minus 4x plus 140. And divide 68. Dividing everything by 68, we're going to get some funky looking equations here, which is very normal for this. So this will be a final answer of y equals, it's a 1 over there, so I'll write it as 1/68 x squared minus, now 4 over 68 I can reduce, so let me just see what is 68 divided by 4, and it comes out to be 17. That makes sense because 4 times 17 was 68. So minus 17x. And then I could probably reduce 140 over 68 too. If you're not sure how to do that, let me show you. 140 divided by 68, and then just hit math, enter, enter, and it'll give you the fraction in simplest form. 35 over 17. So plus 35 over 17. Now one thing we can do in our calculator is check this. What we can check is if we type in our answer, 1/68 x squared minus 17x plus 35 divided by 17, we can at least, first of all, see if it looks like a parabola, but most importantly, I think the easiest check is by looking at the table, and we want to see if the vertex is here, but there's not. There's a mistake here. So hold on, let me just check this really quickly for you. Give me one second. Okay, I figured out my mistake here. So this is negative 4 over 68 is not negative 17. It is negative 1 over 17, of course. And so that's going to still remain a fraction, of course. And so when I type that in this time, 1 over 68x squared minus 1 over 17x plus 35 over 17, and take a look at my table, I do see the point 22. The vertex coordinate is there. All right, let's do another quick one here. But what's different about this question, first of all, they give us a sketch, which is nice, down here. But instead of giving the vertex and directrix, where all we need is P, this time we're giving the focus and directrix. So we need to find both things. We need to find the vertex coordinate, and we need to find a p-value. So they give you a sketch here, but they don't have to do that. But I think the first thing that you should find is that p-value. And p is the distance between the vertex and focus directrix. But since vertex is in the middle, if we could find the distance between the focus and directrix, p is going to be half of that. And that's going to help us find the vertex too. So looking at the focus directrix, again, just looking at the y values, 5 and negative 5, they have a distance of 10, which means that the distance between the focus and vertex has to be 5. The distance between the vertex and directrix has to be 5. So that means that the vertex is 5 below the focus, 5 above the directrix, and it has the same x value as the focus because it's on the same axis of symmetry. So that would be the point 4, 0. So same x value, but 5 below it. So we got a p-value of 5 and a vertex of 4, 0. So I do think the graph helps, and even if you don't have a graph, do a sketch. Define the distance between focus directrix, divide that by 2, and that's going to get you the p-value. And once you have the p-value, you could just, go 5 above or below these things to find your vertex. But the graph, I think, definitely helps you to visualize what's happening here. All right, but let's plug this in now. So it's 4p is 4 times 5, not equals. Let me write the whole equation, actually. 4p, since it's off the screen, y minus k equals x minus h squared. So that's going to be 4 times 5, and y minus the y value of the vertex is 0, equals x minus 4, the x value of the vertex, squared. Let's see, over here, that's going to be 4 times 5 is 20. Y minus 0 is just y. So I'm just going to have 20y equals, my binomial squared will be x squared minus 8x plus 16. Square the front times each other, double square the back. And then just divide by 20. And so these are much nicer numbers than the first example, but this would be 1/20th x squared. And then negative 8 over 20, that can be reduced to negative 2/5 x, right? They could both be divided by 4. And 16 over 20, again, could both be divided by 4. That would be plus 4/5. And so the easiest check here, again, is type it into the calculator. And it's a good thing because, you know, I checked the last answer, and instead of having negative 1 over 17, I just had negative 17. And if I didn't check it in my calculator, I wouldn't have caught my mistake. So I'm glad that I did, because then I would have, you know, 100 students running into class and, hey, you made a mistake in the video. 1 over 20 x squared minus 2 over 5x plus 4 over 5. And let's see if the 0.40 is on our table. 40 it is. That's our vertex. And again, we can take a look at the graph too to see if it does look like what we believe our sketch to be, but it is going to work out. My calculator is just super slow. All right, so that's it for the equation of a parabola from a vertex and distance to focus directrix value. See ya.